Good afternoon, Titans. This is Mr. Sturts, and we are on lesson 4.3. Tonight we are going to write equations of parallel and perpendicular lines. We have two definitions, so pause it here. Write these down in your journals. Parallel lines, two lines that in the same plane that never intersect. Perpendicular are two lines in the same plane that intersect to form a right angle. So pause it and write those down, please. Okay, our core concept, parallel lines, this is the definition we just talked about. They have to have the same slope. Okay, and also all vertical lines are parallel. Up and down vertical lines, they're all parallel. Okay, parallel lines must have the same slope. So if we're looking at these three lines, it says determine which of these lines are parallel. They all look parallel. Okay, but what we need to do is find the slope of each line to figure out which ones are parallel. So we're going to use the same slope formula we've been using over and over again. y2 minus y1 over x2 minus x1. Okay, let's do the first one here. If we do y2, let's say we had 2 minus a 3 over x is on bottom, 1 minus a negative 4. We know minus a negative is the same as plus a positive. If we do our keep, change, negative 1 over 5. So that first line, line A, we have a slope of negative 1 over 5. Let's look at line B. We have y2, so negative 1 minus 0 over our x's, 1 minus a negative 3. Let's do our keep, change. We have a negative 1 over 4. Okay, notice B and A, those are not quite the same. Let's see if C has the same slope. So we're going to do our y2 minus y1 over x2, which is a 2, minus a negative 3. Keep, change. Negative 1, keep, change over 5. Okay, so what we see here is slope from line C, slope from line A are the same. So we are going to say A and C are parallel. Okay, parallel lines have same slope. Alright, our next one, write an equation of the line that passes through 5, negative 4 and is parallel to this line, y equals 2x plus 3. Okay, now a big word, the key word is parallel. Parallel lines always have the same slope. So if we look at this equation, we know our slope of our new line is going to be 2. Okay, because it has to be parallel to this line, to this equation. Now, we're given a point, we're given a slope, so let's use point slope form like we used yesterday. Remember, point slope form, y minus y1 equals m times x minus x1. We're going to plug in. Okay, we are going to, remember, we're leaving our y alone, y minus y1, that's our y coordinate of our given point. Let's go ahead, keep, change right away, equals our slope. Our slope is 2. That's our m times x minus x. That's our 5 in the coordinate given to us. Okay, we want an equation of that line. Let's go ahead and put this in slope-intercept form. Okay, so if we have y plus 4, we need to distribute over here. So we have y plus 4 equals 2 times x is 2x. 2 times a negative 5 is a negative 10. Let's go ahead and move our 4, so we're going to subtract our 4. Y equals 2x minus 14. Okay, and that equation is parallel to this line. Notice our y-intercept's negative 14 in this one. Our y-intercept's 3 up here, but the slopes are the same, so those lines are going to be parallel. Now, they give us 2 points here. They say line A passes through negative 5, 3 and negative 6, 1. Line B passes through 3, negative 2 and 2, negative 7. Are they parallel? Well, we know parallel have to have the same slope, so let's just find the slopes very quickly. Okay, negative 1, we've done this many times before. Subtract our y coordinates. Subtract our x coordinates. Let's see what we get here. Keep, change. We have a negative 4 over a negative 1. So we know that simplifies to a positive 4 over 1. Line B passes through these points. So we have negative 7, subtract our y coordinates. Over 2 minus 3, keep, change. Equals a negative 5. Oh, these are not the same. So are they parallel? The slopes are different? No, not parallel. Okay, they have to have the same slope to be parallel. Alright, moving right along, perpendicular lines. Okay, similar concept, except perpendicular lines form a right angle, and their slopes are what we call negative reciprocals. Okay, perpendiculars form a right angle, that means a 90-degree angle, and their slopes are negative reciprocals. Vertical lines are perpendicular to horizontal lines. So we need to figure out which of these lines are parallel or perpendicular. Okay, first thing, let's put them all into slope-intercept form so we know right where the slope is. Notice line A is in slope-intercept form, so our slope is always the number right before x, or m in this case. So our slope is 4. Now this one, let's put in slope-intercept form. We need to move that x to the right side of the equation. For y equals negative x plus 3. Divide by 4. We got to divide everything by 4. So those are gone there. Y equals negative 1/4. Okay, if there's nothing before the x, we can assume there's a 1. Plus 3/4. Okay, and let's move our line C. Let's make that into slope-intercept form as well. So let's go ahead and add our 2x. So we're left with a negative, added on both sides. Negative 8y equals 2x plus 16. Divide by our negative 8 to everything. So those are gone. Y equals 2 over negative 8. We can simplify that to a negative 1/4 x minus 2. 16 divided by 8 is 2. Subtraction. Now, the only thing we care about are slopes. Okay, we only care about our slopes. Let me throw an x in there. Now, our slope for line B and C, they're the same. They're the exact same, so we know those are parallel. Okay, so we can say B and C are parallel. Now look at line A though. 4 we can write as 4 over 1. A negative reciprocal, all it is remember a reciprocal is the fraction flipped. Now a negative, we just add a negative onto it. So if we had 4 over 1, the negative reciprocal to 4 over 1 is going to be a negative 1/4. Okay, now these aren't equal, okay, but this is what a negative reciprocal is. 4 over 1, the negative, we flip the fraction, add a negative on there. So negative 1/4. So notice, line A will be perpendicular. We'll just abbreviate here. Line A is perpendicular. Look at the slopes for B and C. Negative 1/4, negative 1/4. Those are negative reciprocals to line A's slope. So A is perpendicular to B and C. They'll form at a right angle. Alright, now we need an equation that passes through this point and is perpendicular to this line. Okay, not parallel, not the same slope, perpendicular, negative reciprocals. So we're going to take our slope here, which was 1/2. Let's make that a perpendicular slope, so we're going to add a negative onto it and flip our fraction. So our m is now negative 2 over 1. And we have a point, so we're going to use point slope form. Okay, plug it into point slope form. Y minus our y coordinate, which is 1, equals our negative reciprocal slope, which is negative 2 over 1, x minus our x coordinate, negative 3. Okay, we're going to get this into slope-intercept form. So we need to distribute, and we have y minus 1 equals negative 2x, or negative 2 over 1x. And now we have a negative times a positive, so we have minus 6. Okay, let's go ahead and add our 1 now to get it in slope-intercept form. Y equals negative 2x minus 5. So negative 2 or negative 2 over 1, either way, they're the exact same. We have our negative reciprocal slope. Alright, last thing here. We have a little word problem, little application. We have the position of a helicopter search and rescue crew is shown in this graph. It says the shortest flight is one that's perpendicular, so we need negative reciprocal slopes. We need an equation. Okay, so our first step, we need to find the slope of the shoreline. So we're going to pick out 2 points on the shoreline. Okay, we know that this line crosses at the point 1, 3 and also at that point 4, 1. Now you can use any points that lie on an exact coordinate. Okay, but we need to find the slope. So if we find the slope using, like we said, 1, 3 and 4, 1. Okay, again, we've done this a bunch. Let's find the slope. 1 minus 3 over 4 minus 1. Keep change. We have a negative 2 over 3. That's our slope. Now remember, we need a perpendicular slope though, so we need the negative reciprocal. Okay, so what we actually need to do is flip that fraction and change the sign. So it was a negative 2 over 3, now it's a positive 3 over 2. That's our slope. Now the point they give us on our helicopter path line is 14, 4. So we have a slope, we have a point. Let's use point slope form. So we have y minus our y coordinate, which is 4, equals our slope, our negative reciprocal slope, and then x minus 14. Okay, we know you need to distribute to get it in slope-intercept form. We have a fraction, y minus 4 equals 3/2 x. Now, I'll just do the fraction real quick for us here. This is actually a minus 21 is what we end up getting. Add 4. Add 4. So our final equation is y equals 3/2 x minus 17. And that is our perpendicular equation. Okay, so that's the shortest way that we can get this search and rescue crew there. All right, now that you've taken great notes, turn to page 109 in your student journals. Finish these 3 problems. We'll check them tomorrow in class. Okay, make sure you are doing these practice problems. Okay, they will help you. Have a great rest of your night. We'll see you tomorrow.